Welcome to the East Coast Economic Region of Malaysia, ECER Malaysia, a region covering the states of Kelantan, Terengganu, Pahang and the district of Mersing in Johor. This region is rich with natural resources such as oil and gas and other minerals, vast tract of land and beautiful islands and pristine beaches, with its unique and distinctive culture and heritage, making ECER Malaysia an investor's paradise.
It is indeed an honor and privilege that the Department of Minerals and Geoscience Malaysia, through the Airborne Geophysical Survey project, had contributed towards the development of ECER Malaysia. The project was first proposed during the ECER Development Council meeting on the 9th April 2015, with the objective to identify and delineate areas of potential mineral resources within the ECER region.
The ECER Development Council, ECERDC, is chaired by the Honourable Prime Minister of Malaysia and takes a leading role in setting the direction of policies and strategies to the ECER development. Once this planet was a mass of molten magma. With the passing of eons of time, natural processes led to the concentration of certain minerals to form ore bodies. Constant exposure to erosive forces of wind and rain resulted in leaching and seepages of mineral and metal ions from the ore bodies into the river systems, resulting in the naturally high presence of heavy metals in the surrounding soils and river waters. Through these geological processes, Malaysia too is endowed with significant mineral resources. Malaysia has been known to be rich in tin. It has been found in the western foothills of the central mountains that form the backbone of Peninsula Malaysia. The major areas are the Kinta Valley in Perak and around the vicinity of Kuala Lumpur in Selangor. Tin is associated with the granite rocks. The development of the mineral industry in Peninsula Malaysia could have started as early as the 9th century AD, prior to the conquest of Malacca by the Portuguese in 1511. In early 1900, Malaysia became the largest producer of tin. Malaysia also operated the largest and deepest underground tin mine in the world at Sungai Lembing, Pahang from 1906 until 1986. While early literature referenced the start of tin mining in Perak and Selangor, small amount of gold mining started in Pahang. Other mineral resources like copper, iron, manganese and rare earth minerals have been mined. The Mamut copper mine in Sabah was regarded as the largest copper mine, which also produced gold and silver. Today, gold mining is ongoing in Selinsing and Raub in Pahang, while iron mines at Bukit Besi Terengganu and Bukit Ibam Pahang are notable and still ongoing. The mineral sector has contributed significantly to the growth and development of our economy. The first National Mineral Policy, NMP1, was drafted in 1992 and adopted in 1994. The NMP1 provided the foundation for the development of an effective, efficient and competitive regulatory environment for the mineral sector. Subsequently, the policy was revisited in 2006 and a task force was formed to revise the NMP1. An updated and revised version of the NMP1, which incorporates the principles of sustainable development, is named National Mineral Policy 2 (NMP2). In line with the objectives of the National Mineral Policy 2 (NMP2), we must ensure that the mineral industry's contribution to the national economy and its global competitiveness remains strong. The NMP2 has been specifically formulated to focus on the sustainable development and optimum utilization of mineral resources. In our pursuit for excellence, the mineral sector should be prepared to adopt new technologies and approaches to meet the competitive environment domestically, regionally, and internationally.
National Mineral Policy 2 was formulated 10 years ago, and this National Mineral Policy 2, or in short NMP2, marks another milestone in our endeavor to strategize the mineral sector as an important sector in the socio-economic development of the country.
In 2014, the Ministry of Natural Resources and Environment presented a strategic paper to ECER-DC for the exploration and exploitation of mineral resources in the ECER. The outcome from that proposal, an Airborne Geophysical Survey, was approved by ECER-DC to be carried out to demarcate potential areas of mineral deposits that could be economically mined to help reduce the regional socio-economic disparities, eradicate poverty, and improve income and wealth distribution in a sustainable manner. The ECER of Malaysia covers the states of Kelantan, Terengganu, Pahang, and the district of Mersing in Johor. It occupies an area of 66,000 square kilometers, or 51% of the total area of Peninsula Malaysia. The ECER Airborne Geophysical Survey was entrusted to the Department of Mineral and Geoscience Malaysia, JMG, as the leading geoscience department in Malaysia, and the project was subsequently awarded to Techmark Sendirian Berhad through a tender exercise. Techmark partnered Hisco Malaysia and GPX Surveys from Australia to carry out the Airborne Geophysical Survey.
The project implementation, we have engaged local partner and overseas partners to implement and survey the 6 areas which has been given by JMG.
So my job mainly is in charge for the local logistic, to get the survey crew here and get the like DCA approval, plus also bring in the equipment in time, and especially the contract that we receive have to be completed before the monsoon.
Basic operation was established at Kerteh with the site office situated at Kerteh Airport. Safety instructions were undertaken and an aircraft tracking system set up. The geophysical equipment was installed by GPX Surveys into a PAC 750XL fixed-wing aircraft owned by Kiwi Air New Zealand. The aircraft mobilized from New Zealand at Hamilton on 20th August 2016 en route Auckland, Lord Howe Island, Australia, Port Macquarie, Mount Isa, Australia, Darwin, Makassar in Indonesia, and Miri in Sarawak, and arrived at Kerteh Airport on the 27th of August 2016, taking 8 days to arrive. Before the commencement of the survey, the Malaysia Department of Civil Aviation (DCA) conducted a ramp check of the aircraft. The geophysical equipment, which is installed in the body of the aircraft, was checked by GPX Surveys, and the official visit and the presentation of the system was conducted. Airborne geophysical methods have long been recognized as a valuable geological survey tool since the first airborne magnetic survey was flown in 1936 as part of a mineral exploration program. Airborne surveys have played an important part in mineral exploration programs in many parts of the world over the past 60 years. The high resolution required in such surveys is achieved by low terrain clearance and flight line spacings of a few hundred meters. The surveys form part of larger initiatives to improve the geological knowledge of a country or region, with the ultimate objective of increasing mineral investment and developing a sustainable mining industry. They can also contribute to tectonic reconstruction, groundwater, and environmental applications, all of which ultimately assist societal development. The methods utilized in the Airborne Geophysical Survey, such as magnetics and radiometrics, gamma ray spectrometer, are well known, have numerous applications, and are regularly employed in regional surveys around the world by both government and private organizations. Technology regarding each of these methods has gradually improved, and along with it, the introduction and necessary accuracy in global positioning systems, GPS.
One of the most important things about the quality of the data that we collect is that you have good pilots that can fly straight lines. They also have to maintain a certain height. Because if you change the height of the plane, then you're further away from what we're measuring. And it causes much problems. We're measuring the Earth's magnetic field. So we want to get our magnetometer as far away from the engine at the front of the plane because it does make magnetic noise. So we make sure our magnetometer sits here. But the magnetometer, the instrument, is what we say housed. It is in here. And then there is wire, a cable that comes from that instrument, and I'll take you to down the here as to where you can see it come through. But this is one of the most important parts of the aircraft from the geophysical survey, because that is the magnetometer. And into the acquisition system here. So the magnetics is in this acquisition system. This small box is like a little computer that's gathering all that information. The second thing we're collecting is radiometrics. These two boxes here are called crystal packs. And they have these crystals in it that measure the radiation coming from the ground. And they feed that information again into those acquisition boxes. There's 1, 2, 3 boxes there that are being used to acquire the data that comes together. Up on top of the roof there is a GPS antenna. And the GPS antenna is recording the position, real time.
The both methods of magnetic and radiometric measurements can be effective both directly, as in the location of massive sulfides, or indirectly by providing indications of lithological and structural features favorable to mineralization. The radiometric approach can be particularly important in areas of poor geological exposure or where the minerals sought occur in economic concentrations, which generate no significant geophysical response like gold and silver. The survey commenced on 2nd September 2016 and completed on 3rd November 2016. Over a period of 44 flying days, a total of 62,938 line kilometers, covering an area of 60,189 square kilometers was flown, acquiring magnetic and radiometric data. The radiometric data comprise of thorium, uranium and potassium channels. The survey was flown at a height of 80 meters from ground elevation, giving rise to excellent high-resolution data. This survey was a challenging task to complete in the scheduled time frame without delays before the onset of the monsoon in mid-November.
Actually, this is the third survey. It's been carried out in Peninsula Malaysia. The first survey was actually carried out in 1957, in fact end of 1956 till the middle of 57, and it was done under the funded project by the United Nations, and it was carried out by the Canadian Spartan Airways, and in that project 6 areas were selected throughout Peninsula Malaysia, and basically it was for iron ore deposit exploration, looking for iron ore, and it also involves magnetics and radiometric, and it was also flown as a fixed wing aircraft. And after that, in 1980, the government of Malaysia funded a project over the Central Belt area, and was done through the CGG company, and flown with magnetics and radiometric, because Central Belt was targeted as a potential mineral area looking for base metal. and under this economic corridor, we were supposed to cover this whole economic corridor, which included Central Belt.
Since the Central Belt area forms part of the ECER area, the Central Belt was not reflown, and the previous data set compiled with the new data set. While the airborne acquisition is being carried out, a ground survey was concurrently carried out in establishing the magnetic base station at the Kerteh Airport compound, at Kelantan JMG office ground, and at Mersing area. These magnetic base stations are necessary to monitor the diurnal variation of magnetic earth field and correct these variation from the airborne measurements. The base stations are also used to monitor for unusual magnetic storms that can go up to hundreds of nanotesla, where the survey has to be temporarily stopped until the magnetic storm disappears, which could take hours to a few days. During the present survey, a magnetic storm was encountered at the beginning of the survey and lasted about 2 days, which was also observed as far as Australia. An important part of the survey is calibration and ground truthing of the airborne data. During the ground survey, radiometric instrumental testing and atmospheric calibration over water bodies were also carried out. A radiometric test range was also established, which is required to calculate the radiometric variation with height that is needed to normalize the airborne radiometric data. For this, a 6-kilometer line was surveyed and established. A test measurement was done concurrently from the air and the ground, where the aircraft flew a line and ground data was collected across the exact same position. Also, 3 geophysical lines of about 10 kilometers were done in the north at Besut, center at Kelantan, and south at Mersing, that were used to compare and validate the airborne measurement for its accuracy in both the reading and position of measurement. The acquisition of high-resolution quality data is the primary task. However, if these data are not well processed and interpreted, the data would be of no significance. Therefore, the introduction of the latest image processing techniques allowed a greater range in data displayed that allowed a more comprehensive interpretation and demarcate most potential mineralized areas for follow-up ground survey. The quality control of the data was conducted daily at the site office at Kerteh Airport. Final processing was undertaken at the Data Processing Center in Kuala Lumpur. All aspects of the final processing were presented as a workshop by GPX Surveys. Pre-interpretation workshop and roundtable discussions were held to share data and ideas among the geoscientists from GPX, JMG, private mining and universities to ensure best understanding of the local geology in the field and presently mining areas. A total of 24 thematic maps were produced and about 102 potential mineral prospect areas were targeted for follow-up ground exploration detailed survey. The study also included looking at present mining areas in the ECER like the Raup and Selinsing gold mines, the Bukit Besi and Bukit Ibam iron mines, and Sungai Lembing tin mines as characteristic comparisons. The geophysical data, in particular the radiometric data, help reveal many of the major and minor concealed faults and redefined many of the lithological boundaries. This whole study also revealed new mineralized trends and possible tectonic evolution and geological setting of the eastern bloc of Peninsula Malaysia. The ECER survey provided a myriad of opportunities to our young geoscientists to acquire knowledge in data acquisition, data processing, and interpretation. These were accomplished through various planned training exercises, through on-the-job fieldwork, workshops, and seminars. A successful survey and completion of the reports and maps require good management and diligent supervision. Throughout the survey, a dedicated team from JMG monitored the data and progress of the aircraft.
In the ECER project, I've been appointed as a project leader. My responsible to make sure all the planning in for this project goes smoothly regarding commitment with government-to-government agencies and also with the contractors.
A number of committees were formed to monitor and supervise the progress of the project regularly and allowed open discussion between the groups. Appropriate and quick decisions are made between the client and contractors to expedite the work without any delay. The cooperation and joint efforts displayed by the various groups in the survey were outstanding, and it could be the foremost reason for the successful completion of the survey in the stipulated time frame to get the best results safely and efficiently within the allocated budget.
True highlight was the team effort, all the groups coming together and working to complete the project on time, and I actually believe in budget. It is this cooperation between JMG, Techmark, GPX Surveys, HISCO, Lang, Aragus and Kiwi Air that has resulted in a world-class geophysical dataset. This dataset is a great asset for Malaysia and will definitely aid in the development of the mineral resources industry in the East Coast Economic Region.
The merging of the ECER survey data with the Central Belt data to cover the whole ECER area was indeed a difficult task.
The Central Belt was an area targeted for our mineral exploration, mostly base metal, and now we have covered the Eastern Belt, which includes the Eastern Belt granite, and we have quite good some of the mineralized area. We have some small-scale mining, gold mining, iron mining, and I think the merging of these two sets of data is the most advantage part of this whole exercise. And when we merge Eastern Belt data with its geological setting and structures, we are understanding better the geological structure.
JMG indeed feels proud and happy to have completed this survey successfully and believe this survey will provide a platform for the department to woo more investors to the mining industry with the new set of data from the ECER survey. With the successful completion of the project, an official closing ceremony was held at Zenith Hotel in Kelantan, Pahang on the 30th of October 2017.
Yang berbahagia Datuk Sri Azizan bin Ahmad, Ketua Setiausaha Kementerian Sumber Asli dan Alam Sekitar, Yang Berusaha Tuan Haji Sahar Effendi bin Abdullah Aziz, Ketua Pengarah Jabatan Mineral dan Geoscience Malaysia, Techmark has successfully completed and delivered the scope of work required for this ECER Geophysics Airborne Survey.
Kita dapat bersama-sama pada pagi ini di majlis penyerahan laporan akhir projek survey geofisik awangan di wilayah ekonomi Pantai Timur. Sehingga hari ini sebanyak 102 kawasan sasaran, kawasan berpotensi bagi emas, besi dan lain-lain mineral berlogam untuk kajian susulan di lapangan, dan pengerugian telah dikenal pasti bagi memastikan sumber dan jumlah reserve yang sebenar.
So, selaras dengan objektif survei geofisik awangan SGA di wilayah ekonomi Pantai Timur, kita mahu memastikan bahawa impaknya terhadap sumbangan industri mineral pada ekonomi dan daya saing global kekal. Survei seumpama ini adalah sebagai permulaan penerokaan untuk kawasan sasaran yang berpotensi untuk pembangunan mineral ekonomi selanjutnya. Usaha-usaha Jabatan Mineral dan Geoscience Malaysia ini adalah selaras dengan dasar dan komitmen kerajaan untuk memberikan kualiti kehidupan yang lebih baik bagi semua rakyat Malaysia selaras dengan visi dan misi untuk menjadi negara maju. Saya telah memantau dengan teliti tinjauan ini sejak penubuhannya dan saya menyadari kejayaan dan hasilnya yang mengalahkan.
where Techmark Sendirian Berhad handed over reports and maps to the Department of Mineral and Geoscience Malaysia. This handover ceremony was witnessed by Yang Berbahagia Dato Sri Azizan bin Ahmad, Secretary General of the Ministry of Natural Resources and Environment. He was accompanied by various VIPs from the Ministry, Economic Planning Unit, ECER, Development Council, State Government, JUPAM and JMG state officers. In conjunction with the handover of reports and maps, a short video documentary was shown on the ECER Airborne Geophysical survey. This was followed up with the presentation of the ECER coffee table book to the Secretary General of NRE, Techmark, GPX Surveys Australia and members of the JMG ECER team. A token of appreciation was also handed out by GPX Australia. Lastly, we were all invited to an exhibition displaying the survey equipment and the outcome of the interpreted maps. This concluded a momentous project undertaken by JMG for the development of the mineral sector in the East Coast Economic Region.
I am pleased to note here that overall, the Airborne Geophysical Survey project was a complete success, as it had met its main objective within the allocated budget and time frame.
Deputy Director Generals of the department, with a few members from the ECER team, has this to say.
ECER is an important project to identify the hidden mineral deposit to help the state in the regions to plan land development properly without mineral sterilization.
As an expert on economic geology, I believe the outcome of this project will benefit the nation's development in the mineral industry that will attract investment in our mineral exploration activity.
Important is that this project, when we acquire the data and then we do adaptation, at the end of the day we try to find the target for mineralizations and other types of minerals for the ECER region, and then to develop the mining industries of the region itself.
This project is very important to our country because the result will reveal the mineral resource of the areas and for our future development of the mineral situation.
This is the first time for the young officer to learn about this thing, and the airborne magnetic and radiometric survey is a big opportunity for us.
Overall project, I think is a very great opportunity for me as a young geologist, because as you know, this project is not in every day, almost once in your services.
I think the project is really very great. I think this is a great, maybe I can say something like once it's a blue moon project, you know. So the project will contribute to our expertise.
We thank you for staying with us in this short passage in our ECER Geophysical Airborne Survey. It is not how we approach the situation that is important, but what we finally acquire and have in our hands that is of utmost importance.